Hello, Tiana. Okay, so let us start by resolving horizontally. So we have something going 20 newtons this way, and the key is, because it says it's in equilibrium, that means the horizontal force going this way must equal 20 newtons. So if tension is acting like this, what would that be? That's the opposite, right? What angles here? That's the tension. So this is going to be T sine 25, right? So this is easier than you expect. So it's T sine 25 has got to equal 20. Because that horizontal tension has got to equal the tension going this way because of the keyword equilibrium. So T equals 20 over sine 25, which is part B. What do you think you need to do for the weight of P? You have to resolve vertically. That's something called there's a weight there because it says weight, not mass. So now that we know the tension is 47.3, this vertical is going to be 47.3 cos 25. Now the key is it does say weight, not mass. So mg is included. So all we're doing here is 47.3 cos 25 equals W, and that will equal 42.9 newtons. Because it's in equilibrium, so they're going to equal. Okay, does that help, Caitlin? Yeah, good. All right, do you think you can do question 2? I'm going to help start some of you off. Now, tension is going to be this way. Right, so that's T1. We can call that TA and TB. Now, remember, that's going to be 10G. So you've got to resolve horizontally and vertically at some point, right? I'll give you some minutes to just try to give that a go. If you think you've got an answer, you can type it in. So let's resolve horizontally first. Now, this is the adjacent, so we're going to use cos. So we know TA cos 50 has to equal this TB cos 35, because it's in equilibrium. So we're going to get TA cos 50 equals TB cos 35. So we can say TA cos 50, once we divide both sides by cos 35 over cos 35 equals TB. So let's resolve vertically here. So we get upwards has equal downwards because it's in equilibrium. So we just add the two things going upwards. TA sine 50 plus TB sine 35 has to equal 10G because we've got 10G acting down right here. Now, we've got two unknowns here, we can substitute TB equals this term here into this equation. So our next term we get is TA sine 50 plus TA cos 50 over cos 35. Don't forget the sine, times sine 35 equals 10G. And what do you think you need to do here? What's this next crucial step, people? Luca, Olu, or Caitlin? Just type in the chat box, but if you think it's quicker, you can just speak on the mic. Because this is just making TA the subject.
Wait, did you just say make TA the subject?
Oh yeah, because that's the only way we can solve a TA. So.
Oh yeah.
So because can you see we've got TA in both terms, so we can actually just factorize the TA out.
Okay.
Because otherwise we're not going to be able to get TA on its own. So that would be TA sine 50 plus cos 50 times sine 35 all over cos 35 equals 10G. Let's close that bracket. And can you see that we can get TA by dividing this whole bracket out over 10G?
Yeah.
Yeah, or you could work this out, whatever this equals on the calculator as well, which would be 1.216 TA equals 10G. So TA eventually, once you just work that in the calculator, is going to be 80.6 newtons. And it is asking for TA first. And then to find TB, well, we've got the term in TB up here. And we know TA equals 80.6 now. So I'm just going to change colour so we can see that. Got some space here. So for part B, TB is going to equal what we got for TA, which is 80.6 times cos 50 all over cos 35 to get TB to equal 63.2 newtons. So when you get questions like this, it's not too bad, and you do use resolving forces skills in all forces type questions. Right, any questions about that, or can we move on? Are we okay with that? All right, thank you, Ollie. Okay, so I'm going to move on. I've got question 3 and 4 now. So try to label the diagram yourself. I'm going to give you a few minutes to give it a go, and if you get the answer, then that is excellent, because then that's recap your skill, because obviously you will forget. Now this has the coefficient of friction, right? But it gives you a coefficient of friction. Okay, we said the force is F, that's F. That's got to be F sine 20 and F cos 20. I'm going to let you give that a go, and just let me know if you need me to jump in at any stage to help you. We do have F equals mu r as well, we've got to use. Right, have we got an answer anywhere, or if you're stuck, do you want me to go through it? When it says the value of f here, I'm assuming it's this f that I can afford. Caitlin, you think you've got an answer, or you stuck somewhere, or Ollie or Luca, do you have an answer yet, or you still in the process of doing the question? Oh, you've not finished yet. Okay, perfect. I'll just let you finish. Well done, Ollie. You got a really big number. How big a number, Caitlin? The answer is a 2-digit number, if that's a clue. But let's just see what steps you would have got, because that's an 8-mark question, it says here. So, resolving vertically, we're going to get, obviously there's an R here, plus f sine 20. Now remember, we're going to have this mg, that's why labelling is important. But it's 25, so it's 25g. So that's the only force acting up, R. And this one here, right, that gives us the 2 ones acting up. So it's got to equal, no, because it says it's on the point of sliding, it's virtually like treating it like it's in equilibrium. So that's got to equal 25g. Now, because of F equals mu R, we want to get this in terms of R. Or we could perhaps leave it like that for now. I'm just going to leave it like that for now, actually. But let's just do it just in case. 25g minus f sine 20, because we do need to find what f is. So the only other thing we can do is resolve horizontally. So we're going to get f cos 20 equals, there's the friction, right? So let's do this. F friction is going to act this way if there is friction. So essentially, we could ignore that because we've got F equals mu R. So we've got 0.4. Let's go F max. So equals mu R, which is 0.4 R. So they get confused because this F is a force and this is friction. So here we get R equals F cos 20 over 0.4. Let's call that equation 1. Call that equation 2. So we can sub 2 into 1. So we're going to get F cos 20 over 0.4 plus F sine 20 equals our 25g. Okay, and like before, we take F outside. And that we can get a value for that. And then we just divide this by both sides, this bracket here, and we'll get left with F. We've always worked this out, let's just say that is 2.69 F equals 25g, and F will then equal let me just check on the calculator. 24 times. Okay, so it's 91.1 newtons. Oh, good. So, Caitlin, does that help? Hello, Michael. Okay, good. So that's really important, because if it's not helpful, then I don't want to be wasting people's time. So question 4. Ollie, did you get that, or did you get close? You got some of the method marks, you know, you're resolving up and across, vertically and horizontally, you're going to get some method marks there. And how did you get on with that, Luca, as well? I want to label that to start you off. That's 10 newtons. Got to go perpendicular to the plane. Okay, that's good. You just didn't finish, because sometimes you just have to use those skills. So resolving, that's a first skill. Then realising that you've got to substitute somewhere. If you notice lots of mechanics questions, you tend to need to substitute. Well, that's 10 newtons. And this says find the coefficient of friction between the block and the floor. Now this time we resolve. Let's give you a clue. Because at angle we resolve perpendicular and parallel this time. So that bit there is 26. Help you that with that's 10 cos 26. And that way is 10 sine 26. I'll give you, let you have some time to do that. Oh, you knew sine 20 by accident in the question? Oh, okay. Was that in the question 3 you're talking about, Luca? Question 3. Oh, okay. So if you would have got there, then well done. Because having those skills will get you method marks in lots of other different questions. So that's a good start. And a lot of this is you might remember, some of it vaguely, but hopefully it's all coming back to you. Now, just so you know, because it's important, if the block's about to slide down the plane, friction is going that way. If it's sliding down, friction acts against. So we do start with this. You are. I'll let you have some time to finish. And if you want me to start going through question 4, I can. Yes, please. All right, well done. Yes, so do tell me, because I don't want people to sit there not sure what to go on. So let's go perpendicular to the plane. Oh, I don't know how we all just guess that's perpendicular to the plane. So we know this R is on the point of sliding, so we'll still use an equilibrium type rules. So that R has to equal this 10 cos 26. So that's the only force acting on it. And we know that is 8.99. Sometimes it's just safer to use that whole answer in the calculator. Now parallel, let's just write parallel, resolving parallel. So we know that friction, mu r, because F equals mu r. So we can just call it mu r, because it's asking us to find that straight away, equals, that's got to equal this, because it's going this way. So that's 10 sine 26. Right? So we know R is 8.99 from before. So mu times 8.99 equals 10 sine 26. And then so mu must equal 10 sine 26 over 8.99. And just type that into your calculator. And that makes 0.49 to two significant figures, or you want to do three significant figures, you can. Let's just do 3. 0.488 to 3SF. Okay, I'm going to give you some time to take that down. Right, any questions about that, or are we okay? Okay. Well, Caitlin, did you get there? Alright, good. Alright, so I'm probably only going to do one of these with the time left. Well done, Caitlin. So that is excellent. So you guys, I'll let you guys choose which one you want to do, 1 or 2, or maybe we'll just do 1, and then I'll finish off 2 at a later date because I don't want to keep you too long, and then you can catch up in the video later. So remember, this happens quite a lot. As soon as you see this tan theta equals 0.75, we know tan theta equals 3/4. So you do your little triangle. Okay. Depends how you do this really. So that makes a 3, 4, 5 triangle. That's opposite over adjacent. So that's 3, 4, 5. And automatically just do this at the start. So cos theta must be adjacent over hypotenuse. That's 4/5. I'm just going to write it here. So sine theta equals 3/5, opposite over hypotenuse. It says the block is released from rest. So it's going to slide downwards. It's a rough plane, so it has friction. So if it's going to slide downwards, friction is going to act this way. Still going to have that. It's mass of 2g here. So what's going this way, perpendicular. It's adjacent, so that's 2g cos theta. And that's 2g sine theta. Just remember F equals mu r. That's the friction. We'll just call it F max. And it has given us R. So F equals F max equals 0.2 R. So exactly the same, just resolve. And then I've missed this R out here. So because of time, I'm just going to do this as you can do it. So let's go perpendicular to plane. So R has to equal 2g cos theta. Because we have this and this. Now we know what cos theta is. Equals 4/5. So we can get that to R equals 8/5g. Now think about it. It says find the acceleration of the block here. So we do have to use F equals ma at some point. The block's going to be sliding down this way. So we use F equals ma. What's going this way? We've got 2g sine theta minus 0.2. That's the coefficient of friction, right? Because remember, I've got this purple. And we've got that what's happening down that way, which is this. Because that's our F max. Equals, right, our mass 2, because that's our mass is 2, equals 2a. Now we know sine theta is 3/5, so we can shove that in. 2g 3/5 minus, that becomes 8/25g, because that's a fifth, equals 2a. If we simplify that, that's going to be 22/25g equals 2a. Obviously divide out by 2, but you can just say 11/25g equals a, which actually equals 4.3 meters per second to the -2, because it's acceleration, to 2 significant figures. And that's how you find the acceleration. Right, do we have any questions about that? Is that just adding an additional skill for all doing it? And I'll just advise to take that down, make a note of it somewhere, try it again. So, because that's a lot of marks if it does come up, right?